All right, here's our video on related rates day 2. So our first problem is a shadow problem. So we're going to have a light source and a man walking, and that light source is going to create a shadow, and we're going to find some rates of change. All right, so we have a man 6 feet tall walking at a rate of 5 feet per second toward a light pole that is 16 feet tall. All right, so this is going to be my light pole. Light pole is 16 feet tall. All right, then we're going to have our man who is 6 feet tall. All right, and what's going to happen here is the light is going to shine down on the man, and then that's going to create a shadow. Okay, and then this is the ground, like that. All right, so this is the shadow right here, this whole length. Okay, and both the man and the light pole make right angles. So what we've created here is two similar triangles. We have this small triangle with the man and his shadow, and then we have the big triangle with the light pole all the way over to the shadow. All right, so we're going to do two different questions with this. So here's what we know. We know that the man is walking toward the light pole at 5 feet per second. So that's this distance right here. I'm going to call this x. So the rate of change of x would be dx over dt. And if the man is walking toward the light pole, that distance is getting smaller. So our rate of change should be a negative number, negative 5 feet per second. All right, and then here's what we want to find. So for part A, we want to know at what rate is the tip of his shadow moving. So that is this entire distance, all the way from the light pole to the tip of the shadow. So I need to label this with a variable of some sort. I'm going to go with y. All right, so we want to find dy over dt. That's our question mark, and we want to do that when the man is 10 feet, when x is equal to 10 feet from the base of the light. All right, and so what we can do is we can use our similar triangles. So I have 16 right there divided by y. Just take the two sides, divide them, 16 over y. And that's going to be equal to the smaller triangle, 6 for the man over, and then we need something for this distance. Okay, well, we labeled the entire distance y, and we labeled this distance in here x. So that would make this y minus x. All right, and so that's going to be the denominator of our smaller triangle. Okay, we can do a little bit of algebra before we take the derivative. We can cross multiply. 6y is equal to 16y minus 16x. I'm going to add the 16x to this side, and I'm going to subtract 6y over here. All right, now we're ready to take the derivative. So we get 16 times dx over dt, and that's equal to 10 times dy over dt. We know that dx over dt is negative 5 feet per second. And then we have our 10 dy over dt. So we should be able to divide to get dy over dt. All right, so dy over dt, do this one, is equal to, all right, so 10 and 5 gives me a 1 and a 2. And then 2 and 16 gives me an 8. So I have 8 times negative 1 feet per second, negative 8 feet per second. All right, part B. At what rate is the length of the shadow moving? So the length of the shadow is this. So as the man gets closer to the light source, the shadow is going to also get smaller. So the tip is moving at a certain rate, but the length of the shadow is also moving at a rate. All right, so what we want to do on part B, what we want to find on part B is the derivative of that distance right there. Okay, so it's going to look a little weird. We're going to have the derivative of y minus x with respect to t. That's our question mark, and we're doing it also at when x is equal to 10. Okay, so for part B, all of this over here was part A. So for part B, I'm going to write a little sentence here for our notes. Since where both questions refer to the moment in time where x is equal to 10, you can use your answer from part A to do part B. All right, and that makes this really, really easy, actually. Okay, so since we are working when x equals 10, we can use our answer from part A. All right, and so this equation, remember there's a derivative rule that if you have two functions subtracted from each other inside your derivative, you can just separate it into two different derivatives. So we can do dy over dt. So I'll write it out with the notation I used up here. So d of y minus x over dt is equal to dy over dt minus dx over dt. All right, well, now since we can use our answer from part A, we can plug in -8. So this is equal to -8 minus, and then we already knew that dx over dt was -5. All right, so that's -8. I probably should have included my units in here. Feet per second is equal to -8 plus 5 would end up being -3 feet per second. Okay, and if you think about, do negative numbers make sense? They should, because the man is moving closer to the light source, so the shadow is also moving closer to the light source, and then the shadow is also getting smaller as the man gets closer to the light source because the angle would make it hard for the light source to continue on. All right, so there's your shadow problem. Okay, we're going to do a trough problem. This is going to be kind of similar to our cone that we had yesterday, just doing it with a triangular prism this time instead of with a cone. Okay, so remember that the formula for volume of a prism is equal to area of the base times the height. So for this problem, the area of our base would be 1/2 BH. All right, and then I can't have an H here. This is a different H than I just put here. So I'm going to change that to an L. Okay, so this is going to be an L right here. L is 10. The distance between the bases, H is equal to 4, and then B is equal to 6. All right, so trough is 10 feet long, 6 feet across the top. Its ends are isosceles triangles with an altitude of 4. If water is being pumped into the trough at 9 feet cubed per second, all right, this is what we know. We know dV over dt is equal to pumped into the trough, positive 9 feet cubed per second. How fast is the water level rising? So here's what we want to find. Water level is height, rate of change of the height. dH over dt is our question mark when the water is 2 feet deep. So when h is equal to 2 feet. All right, so for this one, what we can do is we can plug in a number for L. We can plug in 10 because this distance won't change. It doesn't matter how much water is in the trough. The distance between here will always be the same. Okay, so we can go ahead and plug in 10 for L. That's a true constant in our problem. Okay, but we can't plug in a number for H or B because depending on how much water is in here, okay, maybe I should use blue for water. Depending on how much water is in here, connect those together. All right, then this has a B right here, and this has an H right here. Okay, so we're going to have to use that proportion idea again to be able to do this one. So the full trough has a proportion of 6 over 4, and then our water has a proportion of B over H. Okay, look at what we know and what we want to find. We want our formula to be in terms of V and H. So we don't want B in there, which means I need to solve for B right here. So B is equal to, just multiplying by H, I'm going to simplify 3/2 times H. Okay, so we're going to rewrite our volume equation. So volume equals 1/2. Then instead of B, I'm putting 3/2 H. So 3/2 H. Sorry, I wrote 1/3 right here. That's 1/2. All right, and then instead of L, oh wait, then I need my H as well. And then instead of L, we're putting 10, all right, the length of our trough. All right, let's simplify that. I get 3 over 4, and then I get 10. Let's see. All right, let's do this. 2 cancels with 10 to get 5. So I get 15 over 2. Then H times H is H squared. All right, now we're ready to take the derivative. dV over dt. is equal to, multiply by 2, you get 15 h dh over dt. Plug in what we know. We know that dv over dt is 9 feet cubed per second. 15, we know h is equal to 2 feet. And then what we want to find is dh over dt. All right, so I should be able to divide by 30 feet. All right, and we end up with dh over dt is equal to 9 over 30. Those are both divisible by 3, so you get 3 over 10, 3/10. And then this should be in feet per second. So we'll have to, let me look at the units for a minute, and then I'll come back on the video and talk about that. All right, h is a single power measurement. It's not an area, it's not a volume, so it should be to the first power. All right, so I was talking about the units, and I know the units are supposed to be feet per second, and I realized that they wouldn't have worked out here, right? Feet cubed divided by feet would have been feet squared. So the reason that they don't match is because I did not include my units up here when I plugged in the 10. This would be 10 feet right there. So when we get the volume equation, like this 15 over 2 right here, has a feet because I multiplied the 10 in there with those numbers. So that has feet in it right there. So this 15 right here has some feet in it right there. Okay, this 15 has feet. So when I do 15 times 2, I get 30. And when I do feet times feet, I get feet squared. So I was really dividing by a feet squared unit. And so our units do work out. The feet squared cancel with 2 of those, leaving us with feet per second. Okay, so we had this problem on the exam last year. We're actually going to do it down here in 2022 exam, where it was a cone problem, but it doesn't work like the cone problem we did in our lesson yesterday. Okay, so the reason it doesn't work is because they actually gave us more information than we usually get. So usually you get a problem that has 3 variables, but they only give you information about 2 of the 3 variables. So we have to do that proportion thing where we substitute in for the missing variable and we get our equation in terms of 2 variables instead of 3. Okay, so I want to show y'all an example, and then we're going to do the problem from last year's test of what to do when they actually give you more information than you're used to. Okay, so if a related rates problem involves more than 2 rates of change, it's important to ask yourself, do I have enough information to keep all the rates of change? If not, then I need to eliminate a variable for which I don't know the rate of change. Okay, so the length of a rectangle is decreasing at a rate of 2 centimeters per second. Okay, so this is going to be part of what we know. Okay, so dl over dt, it's decreasing, so negative 2 centimeters per second. Okay, while the width w is increasing at a rate of 3 centimeters per second. So dw over dt is equal to positive 3 centimeters per second. All right, when L is equal to 2 and W is equal to 4, find the rate of change of the area. So we want to find dA over dt when L equals 12 and W equals 4. Okay, so what we know is that the formula for area of a rectangle is A equals L times W. Here, I'll use the capital L like we were using over there. L times W. Okay. So on a problem like this, usually they would only tell you 1. So let's like say that they may have not told us the dW and they may not have told us W here. All right, and then we would have to eliminate the W variable from our formula if they had not told us those pieces of information, because we would have to do an equation that only involves A and L. That's how the problems usually work. Okay, but in this problem, they gave us more information. Now we do know something about W, and we do know something about the rate of change of W. So I don't need to eliminate any variables. My equation can be in terms of A, L, and W, And that's exactly what it is. So we are going to take the derivative, and then we should be able to plug all of our stuff in and then find our answer. So dA over dt is equal to, we do have a product here, so product rule, dL over dt multiplied by W plus L multiplied by dW over dt. Okay, we're trying to find dA over dt, so that's going to remain our unknown. dL over dt is negative 2 centimeters per second. W is equal to 4 centimeters. Okay, let me put my units on these up here. And then plus L is equal to 12 centimeters, and dW is equal to 3 centimeters per second. So this is equal to negative 8 centimeters squared per second, and this is equal to 36 centimeters squared per second. And so our answer, dA over dt, is equal to 36 minus 8 is 28 centimeters squared per second. All right, so before we do this last problem, I'm going to revisit that cone problem from day one. Right here. So our original equation, our original formula for volume had a V, an R, and an H. So if we had been given information about dr over dt, and when r is equal to a certain amount of feet, then we could have done this problem the same way we just did that area problem for a rectangle. We would have taken the derivative of this equation, we would have done the product rule, and we would have just plugged all of our stuff in and gotten our answer that way. That's how the problem on the test last year is. Okay, so let's go and let's do a cone problem. But this cone problem is going to give us more information than we got on the one that we did yesterday. Okay, so this was the stem, and so letter D was the related rates problem. So an ice sculpture melts in such a way that it can be modeled as a cone that maintains a conical shape as it decreases in size. So, a real ice sculpture would just kind of melt and turn into just a blob. All right, so we're pretending we're in this fake math world where our cone ice sculpture melts and it stays a cone the whole time. Okay, the radius of the base of the cone is given by a twice differentiable function r, where r of t is measured in centimeters and t is measured in days. We're given values of r prime, the rate of change of r, up here in this table over the time interval 0 to 12. All right, here is our question that we're going to do. The height of the cone decreases at a rate of 2 centimeters per day. All right, so let's start writing down what we know. All right, so I know that dH over dt is equal to negative 2 centimeters per day, D-A-Y. All right, at t equals 3, the radius is 100 centimeters, and the height is 50 centimeters. Okay, so at t equals 3, h is equal to 50 centimeters, r is equal to 100 centimeters. Find the rate of change of the volume. Okay, so we're over here at find. So dV over dt, rate of change of the volume, with respect to time in cubic centimeters per day so when t is equal to 3. And then they give us the volume of a cone here. All right, so there's a hidden known factor. Okay, so when t is equal to 3, remember that they told us that means that h is equal to 50 and r is equal to 100. So we're trying to find the rate of change of the volume at when we know height and r, we know dH over dt. So the hidden known factor here is dr over dt. Okay, another way to write that, we use this notation when we do related rates, but you can also call that r prime of t. And if we're doing it at t equals 3, then this is going to be r prime of 3 is equal to. Okay, so we can come up here and look at this. R prime of 3 is right there in our table. This is negative 5, and it's in centimeters per day. So that's our hidden known factor that we use the table to find. So I'm not going to eliminate a variable. This is the most people who worked the problem and still got it wrong did the proportion thing. They drew a cone, and they set up an r over h equals 50 over 100, and they eliminated the h, and that is not correct. Okay, the reason that's not correct is because the rate of change of r is not the same. It's not a constant rate of change. Look, you can see it in the table. The r prime is different depending on what time it is. Okay, so you can't do the problem that way. It doesn't work. All right, this created a lot of argument among the teachers. Very many teachers thought that the question was unfair. I don't think it's unfair. I think that the problem is that I may have wanted to reword is this part right here, maintains a conical shape. A lot of people assume that meant it maintained a similar cone. Okay, but just because you go from one cone to another cone does not mean those cones are similar to each other. They just are both cones. That's what that means. Okay, so since we can't assume that they're similar cones, in fact, we can prove that they're not similar because of the changing rates of change of r. That means that we can't replace an h variable with something in terms of r, or we can't replace an r variable with something in terms of h. So since we know what h, the rate of change of h and r, we know h and r, we want to find v, we are just going to attack this problem using the formula right here, just as it's written. We're going to take the derivative. So dv over dt is equal to, all right, I have 1/3 pi. That's a constant. So I'm going to leave that alone. And then we're going to do the product rule between r squared and h. So derivative of r squared is 2r dr over dt multiplied by h, and then plus, keep the r squared, multiplied by the derivative of h, which is dh over dt. All right, plug in what we know. We do not know dv over dt. That's what we're trying to find. 1/3 pi times 2, r is 100 centimeters. dr over dt is -5 centimeters per day. And h is 50 centimeters. Plus r squared, so 100 centimeters squared, and then dh over dt is -2 centimeters per day. All right, remember on a free response question, you do not have to simplify your answer. If I am working this problem on the free response part of the test, I am done right here. I've plugged in all my values. I have my units written on there. Okay, yes, the units are kind of all out with each other, but they're correct. If I multiply centimeters times centimeters per day times centimeters, I get centimeters cubed per day, which is what they wanted, in cubic centimeters per day. Here, centimeters squared times centimeters per day is centimeters cubed per day. So I'm going to stop right there. That's my answer. I don't need to do anything else. Okay, if you want to match it up with the answer key, you have to work a little bit more. All right, so let's see if we can get there. All right, so I have my 1/3 pi. Okay, let's see. We have -250 times 2 is -500 times 100 is -50,000 centimeters cubed per day. All right, plus 100 squared is 10,000 times -2 is -220,000. -10,000 times -2, -20,000, and that's also in centimeters cubed per day. So if we combine those together, -50,000 minus 20,000 is -70,000. Then I'm going to multiply by 1/3. Then I'm going to have my pi, and then my units, centimeters cubed per day. So that should match up with the answer key. All right, let me pause the video real quick, and I'm going to pull up the grading guidelines. All right, so if you go to the AP Calculus BC page, you can get this under your AP courses and exams section. You want to go to the exam tab. So if you're on here, there's a tab down here called the exam right there. And then just scroll down, and you'll see the 2022. And they have the scoring guidelines right there. All right, so this is question number 4. So let's see, what is this one? That's not it. All right, here's a table. All right, this is it. And then we want to go down to part D. All right, so you get 1 point for showing the product rule. Okay, so they did it with the 1/3 pi plugged in. They see how they distributed 1/3 pi. We don't have to distribute. All right, you get another point for the chain rule. So that's showing the dH over dt and the dr over dt right there. And you get a third point for the answer. There's our simplified answer, but again, we can leave it just like that. Okay, they did not put any they didn't award any points for units on this problem. So we can probably get away with not putting units. Let's see if they get a global point for units. So sometimes like they just put 1 point for units at the top of the problem and just say you have to show units on these 3 parts to get credit. They didn't do that here. See, this letter A had to include units. That was a point. All right, letter B, they didn't say anything about units there. Letter C, no units there. So they mainly look for units on letter A. But I'm still going to encourage you to always put your units on problems that include units. That's going to be something you definitely want to do. All right, so they have some extra stuff down here, just some notes. If you made this mistake, do you get points? If you did this thing, what points do you get? So I'm not going to read through that whole thing today, but I wanted to show you all the grading guidelines for that. All right, hope you all enjoyed related rates, one of my favorite topics. I will see y'all on the next video.